So instead of solving a quadratic with your completing the square, now we're going to get it looking like when we are graphing equations, where we literally could take one of these and put it in the calculator in y equals and visually see where the answers are at. We're not going to go to the calculator for that today, but it's going to be something we can show you in the future. So, reminder of a couple of things here at the start. F of x is a fancy way of saying y equals. Let's keep life simple. Okay, they are interchangeable. This is your regular vertex form. When we graphed parabolas, we'd look at that before. H and K is our vertex, our center. X equals H, we'll chat about that when we get there, is the axis of symmetry. So when we have these are going to be a little shorter than yesterday. Hallelujah. So, okay, first things first, I'm turning that into y. Okay. Move the constant. You're like, okay, wait a minute, Hardy. What is that again? Let's add a little piece up here. It is steamy in the building today. It's true. I think it's all the humidity from yesterday with all the rain and stuff. So okay, let's chat here. Move the constant. Move your C value to the other side and drop the f of x. In other words, get the y equals, just ignore it, have it out of there. So here's what we're going to do. Job number one. This is no longer here. And to move this to the other side, in this case, we're going to subtract it. So this is going to look weird, but just trust me, bro, on... Once we get that constant to the other side, check out what happened. Our x's are back together, hanging out by themselves, just like they were yesterday. And just like yesterday, once those are on a side by themselves, we're going to put a blank. And we're going to roll that same process back that we did yesterday, which is we're going to take our b value. Okay, even a reminder on the equation over here. We're going to take our b value, sign goes with it. We're going to divide it by 2. And we're going to square it. Always, always, always using parentheses, because this number will never be negative. Ever. Once I get that number, I put that in both of my blanks. We took our b, our negative 10, the number in front of x. We divided it by 2. We cut it in half, negative 5. And we squared it. We're just using this little formula over here, just like yesterday when we were doing our completing the square stuff. So now, we have one more part in this step to get this cleaned up. So negative 5 plus 25 is 20. We need this side to be back in squared mode. So remember, there's a shortcut way to do this. We don't have to factor this out completely, do a perfect square trinomial, any of that stuff. All you got to do is answer me one question. What's half of negative 10? What's half of negative 10? Negative 5. So you're like, wait, so every time whatever number's in front of x, I just divide it by 2, I cut it in half? Yeah. Because now, once it looks like this, we're not solving this time, don't square root it. Move the constant back over, but this isn't going to be to the left side, it's going to be to the right. Hardy's bad on that one. And put your y back in. vertex form. What's that? This 20? It was on this side of the equation because over here we'd subtracted the 5 over, and then when we added our blank to both sides and our blank ended up being 25, negative 5 plus 25 is where that 20 was coming from. What's that? We just use the form, we take half of this and put it into here. So like if this number would have been 6, this would have been 3, whatever that happens to be. We're going to see that a few times today too. It's a pattern. There's a lot of things that go on when we're completing the square that get done behind the scenes, and then it's like, wait, where'd that number show up from? And then we kind of work it through and see. Once we get things back where they belong, your vertex, you see how up here this says x and then that minus h or opposite of h? We're just going to switch the sign on this. So that negative 5 will become positive because of that. The plus k just means we keep that part. So whatever number this is, that's going to be the y value of our vertex. And our axis of symmetry is just x equals, and that same number we used for the vertex. So we use that one twice. This is kind of blending stuff from a couple units ago when we were graphing and doing the vertex and the axis of symmetry there with something new because we've got this in a different form. So what we're going to do, because I believe that was the only, that's the only example I have on there, but that's definitely not enough to get you going. We're going to keep this real close by, though, because we're going to play with several of these. Just, again, to get used to it. Maybe we find something else we want to add to the notes, and that's not a bad thing either. So today, in the practice, back in the practice packet, no additional sheets to put in today. We're going to be on pages 5 and 6. So again, write each quadratic in vertex form, which again, yep, back in the packet. So this is what we're attempting to get our equations to look like. So we'll do a couple up here. This is a little tight on space, so we're going to have to get creative here. So if I do my first one, again, I'm going to try to use my help here to see how things are going. So here's B. Here's C. Those are the only two things I really need to know when I'm doing my work this time. So my first job, get your C value, get your constant to the other side. So we're going to minus that out. This is no longer here for the moment. We'll pull that back later. And our x's, our x squared and our 12x, okay, need their blanks on each side. This is a plus, just got a little sloppy there. So reminder, when I'm trying to figure out the blank, I'm going to try and do that on my edge over here. We're going to take your b value, whatever number's in front of x. We're going to divide that by 2. We're going to cut it in half. And whatever answer we get, we're going to square it in parentheses so we get a positive number out. So in this case, 12 divided by 2 is 6. Squared is 36. That's the number that's going in my blanks. And if you need more space, there's some at the top, or I can get some scratch paper out too. Now it's just cleanup. Negative 32 plus 36 is 4. This side, we're making a perfect square binomial, which is taking the x, taking that b value again, positive 12. What if I cut positive 12 in half or divide it by 2? Just get 6. And if I did side work, it's that number when I did 12 divided by 2. So we're close now to getting what we need, because again, we're trying to get it to look like this. You're like, okay, I see the squared part, so those are the same. To get the rest, we just got to bring that C value, that 4 back over. This goes back to y equals. We took it out before, now we're putting it back. And now I look, yep, those look the same. And so to get these last 2 pieces of the puzzle, we're going to do the opposite of what's inside the parentheses, so -6. And we're going to keep what's outside. It does not mean it's positive every time. And whatever I have for my vertex x is the same thing I'm going to have here. These 2 things will be the same every time. No exception to the rule. So that's going to be kind of our main theme of the day today. Now I'm trying to find one that's going to be different than that. Let's do 3. 3 is going to be similar enough, and I can keep it in the screen enough that we can see what we're up to here, even though I think I can still make this happen. Let's do this. Okay. So I look, first job, x is alone. Undo this, undo my c, my -2. So we're going to +2. That f of x has gone away. So I got my 2 over here now. It's going to get its blank. My x's are alone on this side now. My x squared and my 6x. They get their blank. And just like we did on the problem 1 and on this example, we're going to take that b value, divide it by 2, take the sign with, -3. In parentheses, let me show you again why I stress the in parentheses thing. If I just type -3 squared in my calculator, -9, can't do negatives. That's why we always use the parentheses, because these will always, always, always be a positive. So those are both 9. Clean that up. 2 + 9 is 11. All about patterns. This is always going to be half of this. So -6 halved is -3. So notice, if I do my side work, it's just the number I square. It's what I have in parentheses. It'll always be this number. Just like it was over here. Okay, we divide it by 2. It was +6. There's +6. Same thing. Last step. Get those back out of here. Get your y back in. F of x is fine too if you left it as that. I'm back in vertex form. Again, remember, that is the opposite of what your h value is. So the opposite of -3 is +3. -11. Axis of symmetry, x equals 3, because those are always the same thing. That's all there's going to be to these. There is not as many steps as there are as when you're solving. Speaking of solving, I'm going to look at one thing quick. Okay. I want to peek at one of these. That's going to leave you 1, which is fine. It kind of just lets us see it one more time. So if I need to go back to yesterday's notes, not a terrible idea. They're updated on Classroom, by the way. So if your x's are not alone, we need that done, just like we were just doing up above, except there's no y or no f of x this time. So same blank system, nothing different. Bless you. Still taking your b value, the one in front of x, this one right here. We're going to divide it by 2. Then we're going to square it. That goes to both blanks. Building my parenthesis here, same thing. Take here, we took half of negative 16 was negative 8. Here we're going to take half of 4, which is 2. But this time, instead of getting everything to one side like we would for vertex form, we're solving with the equals here and 0. So this time, we're going to use the square root to make the squared go away. But we're going to remember there's always going to be 2 answers. Because off the top of my head, I don't know. If I was exact valuing it, which you would do in algebra 2, it would be 3 times the square root of 2. Oh dear. So we'll go ahead and we'll get our plus minus if it's not a perfect square here. Decimals are okay. So now I'm going to make 2 equations. I'm going to have x plus 2 equals positive 4.24. And I'm going to have x plus 2 equals negative 4.24. And yep, we'll subtract that 2. And over here we'll subtract the 2. And again, let the calculator help. Negative 4.24 minus 2. Negative 6.24. And again, if you look at the answer key, like for instance on this one, for some reason I decided to go back to tenths. That's all right. If you went a little further, that's fine. If you look down and you see it's tenths and you go to tenths, that's okay too. Again, it's the process right now we're concerned with more than anything else. Okay, so as we've been doing, and we're going to continue to keep doing because, well, yeah, we're getting to that time of year that we're going to need to be starting to go back and catch a few extra things because final exams are coming in a few weeks. So I come back here, I'm like, holy cow, Hardy. This wasn't actually as far back as the square roots and the squared stuff. But still, okay, just a couple of reminders. As we're looking at these, my vertex will always tell me if I'm at a max or if I'm at a min. Remember when we did these? This is not even a month ago. I'm serious. Not even a month. And if our vertex was at the very tippy bottom, that's a minimum. We're down in the valley. So this one, I think, let's see, counting today, that sounds right. Yeah, that sounds right. Well, hey. So we've got our minimum. Our vertex, remember, how far do I go over and down to get to here? So I went right 3. And I went down 4. So many things to keep track of. Oh my. Y-intercept occurs when x equals 0. So here's x equals 0. If I follow that up, the y value there is my y-intercept. I should have done that in a color. Sure.
Figure it out by doing the calculator?
Yes, if I knew the equation to put into my calculator, I could use my calculator, but I don't know the equation this time. Domain, this is the freebie.
Infinity, infinity.
Because no matter what, my x values are always going forever to the left and forever to the right. Now, range, reminder. Lowest y, which just happens to be where your vertex is this time. But we're going up forever. So the rest of these, you can go straight to a calculator, or you can even go straight to what we were just doing. Connection from 2 units ago. 2 units ago, not 2 years ago. It wasn't that long ago we saw this stuff. But remember with these, your vertex, just a little heads up. We just had this on the last page, but your vertex is right there in the formula. There's the H, there's the K, there's the H, there's the K. And your axis of symmetry is just that same H value once again. So you're like, wait, so it really is just like opposite of H and the value on the end. Yep, just like it was when we were doing it a minute ago. And your axis of symmetry is always the same as your vertex x value. The rest of this lets you play with the calculator, so I'm going to back off on that part. But we'll keep playing with this completing the square stuff tomorrow one more time, because again, there's a lot to it. Want to make sure we're good. We're looking at